or TPN, refers to IV administration of the nutrients needed to sustain life. TPNs contain carbohydrates, proteins, fats, water, electrolytes, vitamins, trace elements, and may also include such drugs as heparin. TPN solutions contain base components and additives. Base components are usually mixed first and make up much of the volume of the TPN. These solutions are generally administered by a pump to maximize safety. TPN therapy is indicated for patients who cannot meet their nutritional needs through oral or other gastrointestinal means. TPNs may be used for patients who cannot, will not, or should not eat, or who cannot absorb enough nutrients to sustain their needs. Procedures for ordering and dispensing TPN solutions vary and are specific to each institution. Many institutions use a standardized TPN ordering form to make orders straightforward, consistent, and patient-specific. Since setup to make just one TPN can be costly, this approach saves time and money by allowing multiple bags to be prepared consecutively. TPN solutions are ordered specifically to meet a patient's metabolic and nutritional needs. An order for central TPN solution might look like this. The preparation of TPN solutions has changed considerably in the past several years. In the past, many of the components had to be prepared from non-sterile powders. Today, most TPN ingredients are available as sterile solutions made by gravity fill or by means of an automated compounding device. First, let's look at the gravity fill method. As the name implies, gravity fill uses gravity to transfer the base components into the final container. While gravity fill uses equipment that is normally part of an IV program, the disadvantages of this method are that it limits flexibility in the volumes of base components used. It takes longer than automated methods, and volumes cannot usually be measured accurately. Let's have a look at the two gravity fill methods for filling bags, the empty bag method and the underfill method. The empty bag method involves starting with an empty sterile bag that will be used as the final container. Commercially available bags have leads that can be connected to bottles or bags containing the base components. This method can be used for either traditional or 3-in-1 preparations. Another method is the underfill method. This method uses commercially available underfilled bags, which are partially filled with concentrated dextrose solution. A bottle of amino acids is connected to the underfilled bag by a tubing set and infused into the partially filled bag. With either method, other components are added by injecting them through an injection port into the final container. This is usually the final step before labeling and dispensing. Take great care, both in technique and accuracy, since the potential for errors is high and their ramifications are serious. Each additive must be in the correct amount. If even one is incorrect, the entire solution must be remade. The pharmacist must check each step. We will now talk about automated compounding devices. Automated compounding devices, or ACDs, are specialized equipment used to prepare the TPN solution. Two primary versions of TPN compounders are available. One version provides a separate compounder for the base solutions and for the electrolytes, while the other version uses one compounder to infuse all the compounded ingredients. In the former, 3 primary pieces of equipment are used, sometimes together and sometimes individually. For example, one computer-controlled ACD prepares the base components, dextrose, amino acids, and possibly fat emulsion and water, while a second networked ACD adds most or all of the additives or other components. The base ACD uses special tubing that can withstand the pumping action of the machine in allocating large volumes of solutions. It accounts for the specific gravity of the solutions being used and weighs the amount pumped into the final container. Some ACDs also weigh the original container from which solutions are pumped and stop pumping when the chosen amount has been added. The base ACD can be used with a computer or used alone. When the base ACD is used alone, you enter the desired volume and specific gravity of the base solution components, and the device weighs the correct amounts. The additives ACD also uses special tubing that delivers exact amounts of the solutions in very small quantities. It weighs the solutions to ensure proper volumes and flushes the line between injections to avoid incompatibility problems. The additives ACD must be used with a computer. The computer controls the system and offers many safeguards. It performs many of the calculations that would otherwise be prone to human error and alerts the user to potential entry errors and inappropriate orders. Alarms are available to detect free-flowing ingredients and air bubbles in the line. The final preparations are checked by comparing the anticipated final weight of the preparation against the actual final weight of the preparation. Variances of more than plus or minus 3% are not accepted. The accuracy provided by the ACDs cannot totally substitute for all checks in ensuring the quality of the preparation. Additional safeguards must be built into each step of the TPN ordering, preparation, and administration process. Calculations should be verified, and solutions and their ingredients should be double-checked, regardless of the system used. ACDs are used inside the laminar airflow workbench and must be cleaned daily according to the manufacturer's instructions. These systems require routine maintenance and calibration to ensure accurate compounding. To minimize the potential for errors, the compounder should be observed during operation. Quality control procedures may be implemented to verify final contents of the preparation.